So welcome to today's class, and today our topic of discussion is electric dipole. So we will first try to understand that what is the meaning of electric dipole, and then we will find the electric field of electric dipole probably in the next class. As the name suggests, electric dipole means electric charge of dual polarity. Okay, so we can see here electric charge of dual polarity. As you can see, one single line is there, and on this one side you can see here that a charge is there, that is plus q. Okay, so on one side there is a charge plus q, while on the other side there is a charge minus q. So we are having two opposite charges of opposite polarity, and the distance between these two charges is, so the two charges are separated by a distance of 2a. Basically, midpoint of electric dipole is this, so this is known as the center. So whatever we want to measure, we will measure it from here only, from the center. From plus q to this center, distance is a. From minus q, the center is again a. So that makes up total as 2a. Now there are some points which are noticeable about this electric dipole. Net charge on dipole is 0. So that is your first point. Yes, plus q and minus q will make up the total charge as 0. Second point is electric field is not 0, and we are going to find the electric field of the dipole because it is not 0. So we have to find that at what point electric field will be existing. Third point, direction of dipole is from negative to positive. One of the most important point, yes, because we know that electric field is actually from positive to negative. So this is the direction of electric field, while the direction of dipole is just opposite to the dipole, that is from minus to positive. Okay, so we can say the fourth point, don't get confused between these 2 points. Dipole is from negative to positive, electric field is just opposite to dipole, so it is from always positive to negative. Okay, now the formula of dipole, or we can say dipole moment, is given by, okay, so dipole moment is defined as product of magnitude of either charge and distance between the two charges. Okay, so we can write the formula. As we know that we have to consider only just the magnitude. So sixth point is P is equal to Q into 2A, where P is known as the dipole moment and Q is the magnitude of the charge and 2A is the distance between two charges. Okay, so this is the formula for your dipole moment. If we talk about the units, then we can write the unit as coulomb meter. Okay, because Q unit as coulomb and 2A, so A has the unit of meters, so we can write coulomb meter. So the electric dipole moment, or just we can say dipole, is a vector quantity. That is why a vector sign is also used here. You can see an arrow over the electric dipole moment. A small p is the symbol used for electric dipole moment. Don't get confused it with momentum. Momentum is a different quantity and dipole moment is a different quantity. Okay, I hope so all these points are now clear. Once again we will revise. Electric dipole is a system, an arrangement where two charges are sitting at a distance of 2a and those two charges are having opposite polarity. Okay, net charge on dipole is 0 while the electric field is not 0. So we are going to find the electric field of electric dipole. Then direction of dipole is from negative to positive charge. Direction of electric field is from positive to negative. Dipole moment is defined as the product of magnitude of either charge and distance between the two charges. So formula is Q into 2A and unit is coulomb meter. So hope you would have understood the idea of electric dipole. In the next video, try to find out the electric field which is not 0, and hence, thank you.